Hi everyone, and welcome to week 7 of Coding Squads. Um, so we've only got 2 more sessions left to go now. Um, just so that everyone's aware, the next session, the final one, will be on Monday at 5:30 instead of Friday at 5:30. So that is next week. So Monday, the 24th of July, and that'll be the final session we've got. So what we're going to look at today is some Leetcode problems. So this site, I've used it quite a lot over the last few years. So I'd say it's probably looks a bit intimidating when you're starting out because there's all sorts of problems, all sorts of topics on this site. But I do believe it's quite good for sort of all ability levels really, from when you're sort of learning to program for the first time. There are sort of entry level problems on there. I would say you need to have a bit of confidence with syntax, um, and generally have some problem solving skills to attempt these problems. But there are good ones for sort of people who are sort of just learning. But then as you sort of improve your coding skills and go on to um, take them further, it's really good for developing those skills because you can sort of take it higher and higher in terms of difficulty levels, and there's not really an upper limit. Um, you'll get to some problems that I think most of us will never be able to solve on here because you have such a range, such a range of problems, so many different topics as well. So I'll talk you through sort of the site. So I'll put the link in the description, but it's just leetcode.com. And I'd recommend setting up an account first, so it'll save all your progress. So this is when you've got an account, this is what you'll see. And you want to go to problems. So you click problems and it opens up all the problems that Leetcode has. So I think there's about 2,783 problems. And they're ranked as easy, medium, and hard. So if you're starting out, you probably just want to be looking at easy problems, and then after a bit of time, start looking at some medium problems. So probably after maybe a couple of months of doing some of these, step up to medium problems. And then, as you can see, like with my completed stuff, it's about even between easy and medium. And I've also done a couple of hard problems. The hard problems are hard. You don't really get any sort of easy or hard problems. They are all really challenging, as you can see from me. I've only been able to complete 2 of them. So yeah, if you can only do a few of the easy problems, even just like 1 or 2 of the easy problems, it's still really good. Still really good practice. So yeah, almost 3,000 problems on here. So if we just look at what it tells you, you've got the title of the problem, and they will also have like solutions available as well for some of them. You can see the acceptance percentage, and what this means is when someone submits their code for a problem, what percentage of the time is it accepted? It passes all the test cases. I'll explain what test case means in a moment. We've also got difficulty, as you can see here. Frequency, I think you need premium to look at that. So yeah, you can also pay, I think it's about £10-15 a month or something for premium. So through premium, you unlock extra problems and various other things. But I think just for starting out, having the standard version is absolutely fine. It's only really if you want to take things very seriously, then I'd recommend maybe looking at premium. But I've never personally got it myself. So yeah, there's loads of different topics. Don't worry if most of this seems really intimidating right now. So basically all these topics are for like different data structures. and different types of problems. So you can learn about all sorts of different things, all sorts of different algorithms and data structures on here. It's really good for that. And a lot of people use Leetcode when preparing for job interviews. I think that's sort of the main thing that Leetcode is used for. And it's great for that, but I'd also just recommend it generally for improving your problem-solving skills and learning about data structures, and just generally improving your coding skills. So we're going to look at one or two problems today. So the problem we're going to look at, I'll come back to the rest of the site later. The problem we're going to look at is two-sum. Yeah. Okay. So, yeah, this is the first problem. It is the most well-known Leetcode problem. There are loads of people who've created solutions to this, loads of stuff online that you can look at. So we'll look at this in a minute, but you've got the editorial section, which talks about different approaches to the problem that you could take. You've got the solutions page, which has people's solutions that you can have a look at, and they'll often explain it, and you can comment on them and ask questions, and it's really good. And then submissions, you can view previous submissions as well for the problem. Okay, so let's look at the description. Yeah, the link to the website is in the chat. I'm not sure if I can put the link to this problem, but if you just go to Leetcode and you go to problems, it's the first one there. Or just type in two-sum into the Google and it should appear. So it should be reasonably easy to find. Yeah, forgot to say at the start, but if anyone has any questions, feel free to put them in the chat throughout. If they're more general questions, I'll leave them until the Q&A session in the last 15 minutes of the session to answer. Otherwise, if they're specific to this, I'll try and answer them as soon as I can. I'm just periodically checking the chat every so often. Okay, so firstly, we've got the description here on the left-hand side. So it says, given an array of integers, nums, and an integer target, return the indices, the indexes of the two numbers that add up to target. We can assume that each input has one solution, just one, and you can't use the same element twice, and you can return the answer in any order. And then we have a few examples here, so we can see what the input is. So 2, 7, 11, 15, and the target's 9, and what the output should be. And then it gives a nice explanation as well. So for this problem, we want to make 9, and to do that, we could add 2 and 7 together to get 9. So we'd return 0 and 1 because they're in indexes 0 and 1. And then here you've got the target being 6, number being 3, 2, 4. So you add 2 and 4. And then example 3, target 6, add 3 and 3. Yeah. And there will always be exactly one solution, as it says in the question. And if we scroll down here, we can see the constraints. And basically what this means is what the minimum and maximum sizes of the array and the minimum maximum values of each element in the array, and what the range the target can be as well. I mentioned something about overn squared time complexity. I'll explain what time complexity is in a minute, because this might well be a new concept to most of you, depending on your experience. And then you have some stats down here saying how many submissions were accepted, how many submissions were made, and therefore the acceptance rate. Okay. So let's have a look at doing the problem then. So there are a few different ways of doing this. Now, the initial way you might think about doing this is to have a loop that basically checks every element against every other element. So start at 2, and then we have a nested loop, so a loop inside of a loop that checks, okay, if you sum it up with the second element, will it work? If you sum it up with the third, the fourth, will it work? Now you can do that, and I think the solution will be accepted, but it will be very inefficient. And we'll see in a minute, when you submit your code, it shows you like the runtime and the memory usage, and you want to make sure that that runtime is as low as possible. So when it talks about time complexity down here, that's what it means. So I'll just do a brief aside about this. So time complexity will look usually like this. So you might see O of n squared, or O of 1, and there's a few others, but those are the three main ones that we'll talk about now. So O of 1 is constant time complexity. And what this means is no matter the size of the array, the data set, it will always take the same amount of time to run. So if you have one element or a billion elements, it will take the same amount of time. I should probably put this below to put them in order. O of n is linear time complexity, and this basically means it's dependent on the length of the list. So if I'm not sure if we mentioned a linear search before, hopefully a few of you have heard of a linear search. Basically, it's when you go through each element in a list and you check it against the target. So that basically involves checking each individual element. So you're going through one at a time, going through the entire list just once. That's linear time complexity. But then O of n squared, so that's polynomial time complexity. So this is when not only does it depend on the length of the list, it's the length of the list squared. So this is when you have a nested loop, a loop inside of a loop. So just to illustrate what I mean by that, you could have the iron range 10, and inside that you have the j range 100. So therefore the number of iterations will be 10 times 100, be 1,000. Or just to keep it straightforward, let's do 10 times 10. Skip. Yeah, so that would be 10 squared. Linear time complexity would just be one loop. So just for iron range 10, and it would take just 10 times, 10 iterations. But constant time complexity, there wouldn't be any loop whatsoever. So generally it would just be like, an example of that would be when you access, let's say you're accessing the first element in the list. When you access an index, that's constant time complexity. There's no searching involved at all. So no loops or anything like that. Okay. Right, so we want to create a solution to this that is O of n. So it doesn't. So if we were to do the nested loop where we compare every element to every other element, that would be O of n squared. It'd be very inefficient. And if you look at these constraints, if you have a length of 10 to the 4, so that is 10,000. 10,000 squared is a very big number. So you can imagine it gets very horrible very quickly. However, if it's O of n, 10,000 iterations isn't too bad. It's going to scale a lot better as you increase the size of the data set. So that's the important thing. So we need to think, how can we do this with just a single loop? So just a single, like the iron range length and nums. How can we do that? I'm going to tell you a trick which is really useful for a lot of Leetcode problems, and that is to use a hash table, or in Python we call it a dictionary. So I think I mentioned W3 Schools before, and other websites like Geeks for Geeks, and obviously Stack Overflow. These are really useful sites for learning about how to use different data structures and just generally learning about syntax in Python and other languages. So you can see here, I'm on like the Python dictionaries page, and you've got all these different sections. So you've got like accessing items, changing, adding, removing, looping through, and you've got all sorts of different pages for everything you can imagine in Python, really. And not just Python, but other languages as well. So it's a really useful resource. Okay, so basically what a Python dictionary is, you might think this looks similar to just having a list because we've got a load of items separated by commas, but it's got a key difference. So it stores a load of key value pairs. So what that means is we pass in a key to the dictionary and it passes us back a value. So that key maps to a set value. So you can see in this example, we have a car, and we have its brand mapping to Ford, the model maps to Mustang, and the year maps to 1964. So if we were to pass in brand into the dictionary, we would get Ford back. And that, crucially, is constant time complexity. We don't have to search through the dictionary for that value. It's just, it's there. As soon as we pass in the key, we get the value back. And that's a key difference to a list. Because if we stored a load of values in the list and we were searching for a certain value, that would be O(n). It'd be a linear search, usually. So this allows us to use constant time complexity to access a value, which means we don't have to have this inner for loop. Okay. So we want to use a dictionary. So let's look at how we can define this. So we can see here that we have the identifier, this dict, equals, and then some curly braces. And inside that we can define any initial values. So let's just do that. Just call it this dict, like an example. And let's just have it starting out as mapping 0 to 1. Because you basically have to have something in there initially to declare it as a dictionary so it knows exactly what it is. Python's a little bit weird like that. So yeah, now I'll sort of explain why we're using this dictionary. So here's the trick with this question. We don't need to check if two elements sum up together. So when we get 2, for instance, we don't need to do 2 plus 7 or 2 plus 11 or anything like that, because we know what number 2 sums up to 9 with. We know it's 7, because we basically can say we can say that when we get to this element 2, if we have a 7 in the list, then we return those 2 indexes. However, it doesn't work exactly like that, so not necessarily in that order. So let's start at the first element, and we have 2. And we basically want to ask ourselves, is there a 7 in this list? Now, we could then do a search for a 7. And the way it's ordered, that would work out quite nicely, actually. It's the next element. However, the 7 could be right at the end, or maybe not exist at all. And therefore, potentially, in the worst case scenario, we're still doing we've still got a nested loop, and it would still be O of n squared, because we're searching for an element for each element in the list. And yeah, I'm going through this, I guess, reasonably quickly. So if you do have any questions, feel free to put them in the chat. We will go over everything again as well. It is a bit tricky to understand this at first. So basically, how to get around this is where the hash map comes in. So instead of searching for the 7, we just think, okay, let's store the 2 in a hash map, and then later on, when we eventually get to this 7, we will know that a 2 is, we've already seen a 2, because we've stored it in the dictionary. Yeah, realise I called it a hash map before. So a dictionary can also be called a hash table or a hash map. Those are 2 other terms you could hear for it as well. So let's add to dictionary the mapping of 2 to 0. So why am I mapping 2 to 0? Well, basically I'm saying that we know that a 2 has occurred in index 0. And now when we get to this 7, we can see, okay, we need a 2. Has a 2 already occurred in this list? And yes, it has. And we can know that straight away. There is no searching involved, and that's the magic of a dictionary. And we also know that it occurred in index 0 because we stored that in the dictionary. So therefore, straight away, we know the 2 positions to be returned are 0 and 1, and the program ends. And that's much nicer than having to search for the 2 in the entire list. We just straight away know exactly where it occurs. So therefore, this would be linear time complexity. Okay, so let's have a look at how we can implement it. So, yeah. So inside the for loop, we're going to put the item in the hash map, but first we need to check if the target minus nums I, so the difference between the element and the target, is already in the list, is in the dictionary. Yeah, that's pretty much how you'd write it in English, actually. Yeah, exactly. So we basically say if the value we're looking for, so in 2's case it would be 7 because 2 plus 7 is 9. If that's already in the dictionary, then we return the index where that occurred. So this dict and target minus nums I. And then we also need to return the current index we're looking at. So let's create a new list for this. So we'll just call it answer. And let's just append each one. Or actually, I think we can just shortcut this by using curly braces to define explicit values in the list. Let me just make sure of that. Yeah, should be fine. Okay. So there we go, we've got our answer. So we're getting the index where target minus nums I occurs, and we've also got the index I. Those were our 2 elements. We store that in answer, and we're going to return that. However, if it's not in the dictionary, if target minus nums I is not in this dict, then we put nums I into the dictionary, and we say it occurs at index I. And then, yeah, that is pretty much it, really. I don't think we missed anything. Let me just say that it runs. Missing something here, I think. And it's not is. So it's just target minus nums I in this dict. Okay. So just a recap of what we've just done there. So it was a little bit tricky. So we defined the dictionary up here, and we just put in 0 and 1. Now, just thought as well, we probably need to remove this. So we'll remove the mapping of 0. The reason I put 0 to 1 in there at first is to specify that it is a dictionary, because in Python you can't specify data types explicitly like you can in other languages. So you need to sort of do it this way, which is a bit weird. So anyway, I'm removing the 0 just in case we have a 0 in nums, and therefore it could have the incorrect mapping, and it could cause some issues. Okay, so we've got this for loop that goes through each element in nums, and basically if if target, actually yeah, that's pretty much English to be fair. If the target minus the element we're looking at, nums I, is in the dictionary, then we found two matching items. So we found two items that sum up to target, and we return the answer. Otherwise, we just put the item into the dictionary, mapping to index where it occurs. Yeah. Okay, I'll just write some comments about the general approach here. So generally what we are doing is storing each element in the dictionary, mapping to the index where it occurs, checking for each element if it can be added to another element we've already seen in the dictionary. So for in the list, check if it can be added to this to make the target. And you keep going until you find two numbers that sum up to make the target, and then you return the indexes where they occur. Okay. And yeah, that's something I'd recommend generally with programming, but also with Leetcode problems, writing some comments. Generally, I'd write them beforehand about what your plan is for what you're going to do, but it's also good to sort of write them after you've written your solution, just so you can sort of think, what have I just done there? And it helps sort of you reading through your code and understanding whether you've like done something wrong or something. And also looking back at problems as well, you can understand your solution. So it's really good to do. Okay, so you can see down here we passed all 3 test cases that are listed. Now there are some hidden test cases. I think for this one there are about 250. So we have to make sure that our code works for all hidden test cases. Now in this case I don't think there will be any issues, but sometimes some common things to look out for is when you could have an empty list and having to deal with that. So a lot of people will just assume that the list has items and straight away try and access them. If you've got an empty list, it will give you an index out of range error. So you have to bear in mind all these different things. In this case, the length of the numbers is at least 2, so this should work. There's no reason it shouldn't work with large elements or negative elements either. So there shouldn't be any problems at all. So yeah, we can see how it ran against the different test cases. It said what was expected, what was outputted, and it matched. So therefore, all 3 passed. So let's try submitting that. Don't think there should be any issues. Oh, okay. That was strange that it worked the first time then. Okay, yeah. Not sure why it didn't flag that up initially, but anyway. Yeah, let me just make sure. I think this might be, it may be delete, not remove. Let's just try with this actually. Okay, it worked anyway. Yeah, so I think you probably can just specify this dictionary using the curly braces. I think sometimes you'll need to put values in it for certain data structures, but for a dictionary I think it's okay. So just don't worry about that for now. Okay, but yeah, seems to be working fine again now. Let's submit it. And it gets accepted. Okay. Right, so we can see our runtime, we can see our memory usage. So we go to runtime. It's not very useful here because I think everyone has the same runtime. So what you can see here is 41% of solutions have got the O of n time complexity. And then I think this is pretty much like, well, a little bit under 54 squared, but you can see this is O of n squared. So you can see this is 54 milliseconds, this is about 2,272. So 15.5 solutions did it O of n squared, then about 5% over here as well. So yeah, there were basically 2 ways of doing it. One with a hash table, a Python dictionary, and then the second way was brute force. Memory I generally don't pay much attention to. Runtime's more important for Leetcode problems. If we go to the editorial, it lists the different solutions. Now most problems won't have video solutions, but because to some such a famous problem, this one does. So it says, yeah, you can use brute force as we discussed before, and it gives you the code for this. So it's just a nested for loop. If they sum up together, return the indexes, but that is O of n squared as it says. And then here is the one we did with the hash table. So we used a dictionary. Yeah, I think we did it with 1 pass, didn't we? Not 2 passes. Yeah. So this is about sort of the one we did. Pretty much the same. And you can see this one has O of n time complexity, O of n space complexity. And as we said, each lookup in the table only costs of one-time complexity, which is really important. Yeah. And then you've got comments down here where people have shared their solutions, and you can also go to the solutions part where people have shared their solutions. And if you're stuck on a problem, this can be a good way to learn about how to do some of these problems. Look at other people's solutions. They also talk about their approaches and give sort of a plan of how they've done it. And you can view the solution in different languages. So you can view in Python, Java, C++, depending on what's been done. So yeah. So you can see all the different approaches for a problem. So it's quite useful. Okay. Right, so we've got a few minutes left. So I'll just talk about a few other things on the site to look out for. So if we go to contests, these are quite useful. So basically on Leetcode, you have weekly and bi-weekly contests. So weekly contests, you don't have to do them live, and I wouldn't recommend doing them live if you're in the UK because they're at 3:30 in the morning. Bi-weekly are at 3:30. I mean, there's one tomorrow, but you can just do them in your own time, so you can launch the virtual contests and sort of do it in the contest environment, but it doesn't really make too much difference. So if we look at, this is the last weekly contest, and you'll have people do this really competitively and compete to win prizes and stuff. So like if you look at the rankings, this is a little bit silly because some of these, well, all these people are quite ridiculous, to be honest. So you can see the time people have taken to do questions, and you can see their solutions as well. But yeah, don't worry about how long you're taking to do solutions. These are people who've been doing this stuff for years and doing it like crazy, spending so much time practicing, surely, and probably do it competitively. So I think as a beginner, I would just be looking at this first problem, maybe the second problem once you get a bit of experience, and then really only looking at the third problem once you're fairly confident with Leetcode. And then if you ever get onto looking at the fourth problem, then you're very good, because that's usually quite difficult. So if we look at the first problem, for instance, you can see like how many people are being accepted, how many people tried. This is a good indicator about how easy a problem is, how easy or hard it is. If you've got loads of users being accepted, then it's a good sign that most people can do the problem. And don't worry if you can't yourself. Again, Leetcode problems, I say they're good for all sorts of levels, but you've got a wide range of people on Leetcode. You've got some people who will do this problem in 20 seconds, and you've got a lot of people who will spend quite a while trying to figure out the problem. And just if you can just have a go at the problem, and maybe initially you can't really do it without a bit of help, you have to look at the solutions, that's absolutely fine. If you have to look at solutions for a bit of help at first, absolutely do that. Don't let it put you off if you're struggling with these problems. So yeah, so you can see this one here, sum of squares, special elements. I won't talk through the problem now because we haven't really got much time. But yeah, the first problems on contests are usually quite good for beginners, I think. But then you can see once you get to the end, last problem, only 1,100 have been accepted, whereas the first one had 15,000. So you can get an idea of how difficult the problems are. Okay. So yeah, you've got, I mean, this is weekly contest 354. So there's so many contests on here, you can just do them whenever you want. So yeah, as a beginner, I'd recommend trying the first problems on each of these. Then some of them can be a bit tricky, but some of them aren't too bad. And you can always look at the solutions as well. So what I usually do, if I just go back to the problem, because you can't view it on here, but if you just Google, like copy and paste this into Google, then it will come up with the main Leetcode page, and you can view the solutions on there as well. And you can view people's explanations. I'd use that rather than viewing like contest submissions and their solutions, because in the main Leetcode pages you can view solutions and explanations as I showed you before. So you can always use that if you're stuck. Yeah, loads of contests. Try the first questions and then see how you go, really. There's also an interview section. I think most of you probably won't be looking at that just yet. But that's good for if you're using Leetcode to apply for jobs and stuff. There's also a forum. I think this is mainly for interviews, to be honest. And then once you're a bit more confident with Leetcode, you can try some of these courses as well. So, for instance, I started this one a while ago. You've got a course about binary trees. So if you want to learn about binary trees, it gives you some notes, and then it gives you some problems to try as well. So it's quite good for learning about these. But if you're a beginner, I'd focus more on just getting used to Leetcode, making sure you understand the syntax of Python, and just doing the sort of easier problems first to build up your problem solving skills, and then maybe going on to these. And this is really good if you want to learn about a specific thing in detail. Yeah. Okay. Don't think anyone has any questions. I don't think there's anything more to talk about. So I think next lesson I will sort of go over general tips for debugging issues in your program. So I'd like to have a look at debuggers, and also just generally how to Google when you're stuck with a problem. Because I think this is a really important thing when people are starting out with programming and working their own projects. They can get stuck on small issues because they're not really sure how to tackle them. And there are loads of useful tools out there, debuggers, obviously Google, and even like AI for helping spot errors in your code. So I'll discuss a bit about that. That's a really important thing. We can maybe have a look at another Leetcode problem if people want. And I'm also happy to look at some GCSE pseudocode questions if people want to do that as well. So yeah, the final session is Monday at 5:30, not Friday at 5:30. So make sure to join on Monday, and hope to see you there. So thanks for joining. I'll see you on Monday.